Okay, nominal data versus ordinal data. I'll just go over that again. So, they're both categorical. The order of the categories is arbitrary. Here there's a logical order. For example, it can go from strongly agree to neutral to disagree strongly. Do you see how there's sort of a logical ordering to these categories? So both of these are categorical and qualitative. No order here. Here there's order. Okay, primary data versus secondary data. Primary data is the data you collect. The researcher collects this. You might do an experiment, you might do a survey, whatever. Okay? Secondary data is data collected from other sources. So you might use a database that's available on the internet. There are very when you do your research project, well, most likely you'll be using secondary data that you'll get off the internet. We'll keep it simple. Experimental data versus observational data. Experimental data is data produced by an experimental design. It could be quantitative or qualitative data depending on the investigation. Clinical research, testing of new automobile fuels, testing of new medicines that they're producing, right? Whatever, will most likely use experimental data because they don't want side effects, so they like a little bit more control. Observational data is just data resulting from noting and reporting something about the population. Observed characteristics, qualitative or quantitative. It is often subjective. Drawing inferences about the effect of treatment on subjects. Are there side effects? You're observing. Recording the behavior of animals at various times of the year. You're just recording behavior, observing, and trying to get information. Microdata versus aggregate data. Microdata is all that little information you have on each individual. For example, in your, what's your student record called? SR, Ontario Student Record, OSR? I think it's OSR. You, sorry? Yeah, sorry? Ontario Sec. Uh, OSSR. In there, they have your name. They have your birth date, maybe. They have your grade 10 math mark. They have all these details about you, don't they? They have your grade 11 math mark, right? All this is microdata, right? That's considered microdata. Aggregate data is when, well, it's summary level data. It's the result of applying statistical analysis to micro level data. So they might calculate average grade 10 mark. Okay? For YMCI. So when you start applying statistics to micro level data, you get aggregate data. Let's do an example. Data was collected on the seating capacity of different makes of vehicles. The data collected can be identified as qualitative and continuous, qualitative and discrete, quantitative and continuous, quantitative and discrete. So when we talk about the seating capacity of different makes of cars, which one would probably best apply? Huh? Quantitative and continuous. So, huh? Yeah, quantitative and discrete. So because we're counting, right? It's a number, and you can't seat 3.789 people, right? So it's quantitative and discrete. Okay. No, primary data. Primary data. Some of these concepts such as randomization, replication, and control apply to both primary and secondary data. So remember, primary data is when you collect the data yourself. You're finding your data either by questionnaires or you're doing your experiment. But some of these terms also apply to secondary data as well. Let's talk about randomization. Let's say this class is my population. Let's just say I'm going to pretend that you're my population, okay? This data class is my population. And I want to find out what's the most popular type of music out there. Well, I don't want to survey all 30 of you or 20 of you, how many are here. I might just want to sample 5. So, would you say the following is a random sample if I go 1, 2, 3, 4, 5? Is that random? Yeah. Not to a statistician. Okay? To a statistician, that is not random. Okay? So, what happens is, you don't know, I might have just picked everybody with certain characteristics. Maybe everybody with black hair. I didn't pick any blonde-haired people, right? So when the researcher picks their own sample, it's not considered random. It's only considered random when we use a machine to calculate it. Like, in order for it to be random, I would have to give you each a number, or I could put each of your names in a hat, shake it up, and then pick it out. Or I could give each of you a number, then use a random number generator, let the random number generator select 5 people. Let a machine or a computer do it. Then it's random. But if I do it, it's not random. Can I explain that better? Huh? We're good? Okay. That's important. So, for randomization, we need a random number generator. For replication, we either have a large sample size or we have many samples. For control, we're trying to control other variables that may affect your results. Okay, so I thought I had a Let me just show you an example. Let's say I have number of hours studied versus your mark. And usually when the number of hours studied goes up, not always, right? We try to get a line of best fit. Usually when the number of hours studied goes up, the mark goes up. What are other variables that could affect your mark? Can you think of other variables that might affect you? Huh? Intelligence? Anything else? Yes? Time management? Huh? Health at the time? Yeah, what if you're studying and when you have a headache or you have the flu? Yeah. Sorry? Yeah, maybe efficiency or effectiveness. Anything else? Huh? Time you study? Or, yeah. All right, when you study. Morning versus late at night. Yep. Could be, yeah. Where you study. Also your teacher, right? We can't. Teachers have to be careful too, right? Huh? English skills, language skills, sure. Accent? Like accent of the teacher? Okay, so how could we maybe control some of this? So you might do a study number of hours studied. Like what if you want to control intelligence? You might just do, you might only study people with IQ between, I don't know, 90 to 95 as an example. That way you have a certain group of people with the same intelligence, approximately, right? All right. Randomization of the data ensures all members of the population are equally likely to be selected. I have a section here on we'll use, for you to get your random samples, we're going to use a random number generator. Okay. Such techniques reduce the likelihood that the results will be inappropriately weighted in favor of one particular group. So this is very important, that when you pick a sample, you pick a random sample, and this is gonna come up quite a bit. Randomization, alright, so sample statistics from a single, alright, let's focus on randomization first. Alright, so let's jump ahead. We're going to do something on randomization and then we'll come back to 7 later. If you flip ahead, you will see something called simple random samples. We'll just do these exercises today and then we'll call it a day. It doesn't have a page number on it, okay? It's just an extra handout I found which really explains simple random samples quite well. I will highlight what is the most important. Did everybody find it? Yeah, it would be page 14, but it's not numbered. All right. Okay. In a voluntary response sample, people choose whether to respond or not. People have a choice. Do you mind filling out my survey? Some people. In a convenience sample, the interviewer makes a choice. In both cases, personal choice produces bias, and we're going to spend a day on just on bias, okay? A statistician's remedy to allow impersonal chance to choose the sample. Right? A sample chosen by chance rules out both favoritism by the sampler and self-selection by respondents. Okay? The way we do this is, what we want to do is make sure rich and poor, young and old, black and white, all have the chance to be inside this in the sample. We want it to be random. The simplest way is to place names in a hat and draw out a handful. So one of these is using a hat, right? We can do that. That's acceptable. However, what I'm going to show you today is how to use a random number generator, okay? So here's the definition of a simple random sample. A simple random sample of size n consists of n individuals from a population is chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. So what they're saying is, we don't want any bias in our sample. We don't want the statistician to be selecting particular individuals over another. Maybe I don't want to give you that kind of an example, but I don't want to just choose people who get A's. I want people who get A, B, C's, D's, and maybe fail. I want everybody in the sample, right? I don't want it to be biased. When you think of a simple random sample, think of drawing names from a hat so that you do not favor any part of the population. Okay. So there are random number generators that you can find. The TI calculators have it. You can get them on the internet, but what we're going to do on the test is use a random, we're going to use this table. On the test you will have this table, and you will use this table to select a simple random sample. Okay? I'm just trying. So we're going to use a table of random digits. Is a long string of digits. They use all the digits from 0 to 9 with these two properties. Each entry in the table is equally likely, and the entries are independent of each other. So we're going to use that table, and you will have that on your test. So what we're going to do is give each member of the population a numerical label, and I'm going to do this with you, and then we'll choose a simple random sample from the table, and you use successive groups of digits of the same length, and the sample contains the individuals whose labels you find in the table. So that's a bunch of wordy stuff, but I need to show you how to do it. So we're always going to use the shortest labels that will cover your population. So let's do some examples so this makes more sense to you. Here's an example of a population. There are 28 resorts that are in the population. They want a sample size of 4, right? So we have 28 resorts in our population. We want a sample size of 4. Okay? What they've done is they've labeled it. Since there's 28, they labeled it 0, 1, 0, 2, 0, 3. Because there's 28, your label must have 2 digits because the total is 28, right? Because there are 28 resorts. So this is 2 digits, so your labels must be 2 digits, right? So they labeled them for us. Okay? And when we go to the random number generator, we're going to read by 2. So let's look at that. Now they want us to start at line 130. Okay, let's go to the table. Let's go to line 130 and read off by 2. Here's line 130, 69. Well, we only have 28 resorts, so 69 is too long. So we're going to choose resort 05. So resort 05, actually they have it for us here. Resort 05 will be the first resort in our sample, Beach Castle. Right? Now let's go, the next one is 16. So the next resort is the Radisson. Next one's 48. That's too big. We only have 28. The next one is 17. So the next one in our resort is Ramada. The next one is 87. That's too big. That space in between the digits is only to help your eyes read. You can 17. Oh, we already have it. 40, too big. 95, too big. 17 already have it. 84's too big. 53's too big. 40's too big. 68's too big. 89's too big. 87, the next one is 20. 20 is Sea Club. Makes sense? So first you label each item in your population. And then you use the size of your label to, you're always reading off 2 digits at a time. Okay? It's basically the technique. Let's do a few more examples. Can I just point out something to you? You can notice how they do this. You can label up to 100 items with 2 digits. See how they go from 0, 1? Instead of writing 100, they write 0, 0. Because they want each label to have 2 digits. Up to 1,000 items can be labeled with 3 digits. So you would go 001, 002, 003, all the way up to 000. But don't worry, this usually is not an issue on most samples, so I'm just making you aware. Always start with the label, like if it's 4 digits, you'd be going 0001. Don't call it 1, right? Because your label should have, you're reading off equal amounts for each item you want to select in your sample. Let's try another guy. Okay. You are planning a report on apartment living in a college town. You decide to select 3 apartment complexes at random. So your sample size of 3 at random for in-depth interviews with residents. Use table B starting at 117. So they want us to start there. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like there's 33 in total. So we're going to start, our label will have 2 digits. So this is 0, 0, no, sorry. This is 0, 1, 0, 2. Just label. That should be 5. 0, 6, 0, 7, 0, 8, 0, 9, 10, 11. Okay, so now we have our label. They want us to start with line 117. And they only want 3. Thank goodness they don't make us do. So we start at line 117. So number 38, that number's too big. So number 16 is the Farrington. So our first item in our sample is the Farrington. Okay, let's keep going. 79 too big, 85 too big, then it's number 32. So 32 works. Waterford Court. 62, 18 works. 18 is Fowler. There's our sample. Okay? Can I explain anything better? It's good. Let's try this one. What happens when we reach the end of a line? What do we do then? What happens when we get to there and we... Let's look at that. That will be illustrated in the next example. We have a really slow response time in this, don't we? Isn't that weird? Have you ever seen that before when it's that slow? Sorry? Okay. A firm wants to understand the attitudes of its minority managers toward its system for assessing management performance. Blah, 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 blah. Oh, they want 6. That's what I was looking for. Okay, so again, there's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. There's 20. No, there's 28 in total. Therefore, 2-digit label. Zero 1, 0 2, 0 3, 0 4, 0 5, 0 6. Remember, don't start with 1, start with 0 1. 0 8, 0 9, 10. Okay, so we've labeled. Sample size is 6. Let's do it. Who's going to be in our sample? They want us to use line 139. 55's too big. 58's too big, 89's too big. Oh, 04 is our first one. 04 is bonds. Right? 04 is bonds. 70, 70, 84. Next one is 10, Fleming. 98, 43, 56, 35, 69, 34, 48, 39. Oh, 17. 17 is Lumumba. Next one's 19. 19 is Nguyen. Now we go, when you run out when you get to the end of the line, you just go to the next one. 12. Gomez. We need 6. 1, 2, 3, 4, 5. We need one more. 97, 51, 32, 58, 13. Last one is Gupta. Good? Any questions? Okay. Let's do this one. All right, a local genealogical society. They have 55,914 gravestones. How many digits should our label have? 5. So A. They would be labeled like this: 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All the way up to 55914. B. Who would be in our sample? They say begin with line 120. So let's go to line 120. So we're going to read 5 off at a time. Oh, 35. So tombstone number 35435476 is on. 55972. That's too big. 39421. 65's too big. 04266. 35435. How many do they want? So we need one more. 43742. Yep. It's just for ease of reading. Yeah, they're grouped, guys, they're grouped in terms of 5 just to help us read. Just to facilitate reading. They had some random number generator like a computer or a calculator or whatever. The first one they had 0, 0, I guess line 1, line 2. You know, this is just some record of it. I don't know. No, I'm not sure why they started with that. I guess I'm not sure in all honesty. I'll tell you which one, otherwise I'll have all different answers. Yeah. Any other questions? Like there's different random number generators if I were to Google. Oh, you know what? Ah, here. Let me stop recording.